Hey guys, today we'll be covering the MRSM 2020 paper 1. So if you guys don't have the paper, you guys can refer to the description down below. There is a link there that will lead you to all of the past year's papers. I've compiled all of them in a Google Drive so you guys can download them and print it out and make use of them. I have set timestamps for every question in this paper, so if you guys have a specific question you want to refer to, you can go to that question, or if you want to go through the whole video, you can go right ahead. And also, if there is any parts or any points of the video which I made a mistake, please feel free to leave a comment and to notify me about it so I can make the correction using captions, and I'll edit the video a little bit by then. Right, so without further ado, let's get started. Right, so question 1 is given that a multiplied by a multiplied by a dot 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 until a p plus q times multiplied by a times a q times is equals to the square root of a to the power of n. So what we have here is we can actually refer to the laws of indices. So we have the law of indices where we say that am times an equals to am plus n, right? So based on this law, we know that if you multiply terms of different powers, we can actually combine them, we can actually play with the powers in that sense. However, if we multiply terms like this, such as a times a times a, right? So if I said 3 times in this case, intuitively we know that we can say it's a to the power of 3 because it's a power 1, a power 1, a power 1, so it's 1 plus 1 plus 1 according to the indices law. So if I said it as p plus q times, so logically I can write it as a to the power of p plus q, and I can put a bracket there. And for this part they said q times, so I can write it as a to the power of q, so it's equals to the square root of a to the power of n. So from here I can apply the first law of indices here that I have mentioned. So it is a to the power of p plus q, because this is also a multiply. When you see two brackets together without any symbol, we consider that as multiply. And square root of an, we can convert it to index form by using another indices law as a fractional index. So a to the power of m over n, which is n root a power m. So the numerator represents the power, whereas the denominator represents the root. So it is the nth root a to the power of n. So in this case, this is square root, because when there's no number here, we usually refer it as square root. So it will be a to the power of n over 2, because the power here is n. So since their base numbers are the same, we can actually play with the powers here. So it will be p plus q equals to n over 2. So they want n in terms of p and q, so it's p plus 2q multiplied by 2 equals to n, because we multiply 2 on both sides. So it will be n equals to 2p plus 4q. Oh yes, I forgot to mention earlier. Please pause the video if you guys want to attempt the question, or if you guys would like to see the next solution, because I would do questions. I won't leave any lag in between the questions. So please pause the video if you guys would like to attempt the questions. So moving on. So question 2, log k5 equals to t, and log 5 to the power of 3n over k squared. That's a bit small. Yeah, I think it's 3n. So equals to k, over k squared. So from here, they ask us to express log 5 to the power of 3n over k squared in terms of n and t. So we can play with the law of log here. So we have some log laws to work with. So since there's a divide here, we can play with this log law. So we have a log law here says that log AB minus log AC equals to log AB over C. So since we know this, we can convert it into two terms in this case. So we have log 5 power of 3n minus log 5k squared. And again, we have another log law to apply. Log AB power C. If there's a power on the term next to the log, we can push the power to the front. So I'm going to move the powers to the front here. So it will be 3n log 5 minus log 5k. And from here, another log law to use. We know that if your base and this number is the same, we know that the value is 1. Another log law to use here. So 3n times 1 minus log 5k. And from here, so the question gave us log k5, but you notice that the base and the number here is different. So we can actually apply another log law where we change the base, where if let's say I want to change the base to b in this case, log ab, so it will be log bb over log ba. The old power goes to the front and replaced by the new power, right? So in this case, I'm going to change the base to k to match what the question has given me. So 3n times 1 is 3n, so it will be log k over log k5, right? So from here, I'll have 3n minus 1 over log k5 is given as t, so we have 1t here. Oh, right, I forgot about this. So there's a 2 here, and a 2 here, and a 2 here. So this is 2 times 1, so 3n minus 2 over t. And this is solved. So question 3, diagram shows some relation between the x and y coordinates. So state the type of relation between the x and y coordinates. So I'm just going to put down all of the x and y coordinates here. So it will be negative 2, 1, 2, and 5. And y coordinates is 1, 4, and 25. So negative 2 is attached to 4, and 1 is attached to 1, 2 is attached to 4, and 5 is attached to 25. So we can see that there is more than one object that goes to one image, so we can call it a many to one relation. So how we differentiate the relations is basically the first word represents the objects and the second word represents the images. So in this case, there is more than one object going to one image, so we say many to one in that sense. So this is A. So for B, the function notation of the relation. So function notation is written as f colon x arrow, and we put the equation down, right? So we need to see the relationship that this function had, like what is the relationship between the numbers here. So object negative 2, image is 4, object 2 also 4. So we can understand that we can see a very clear pattern here. In this sense, we can say that 2 square is 4 in the same way that negative 2 square is also 4, right? So we can write it as fx equals to x square in that sense for this function notation. So C, the objects of 16. So objects of 16 basically means that 16 is an image because we are looking for what could be the object of 16. So what could give me 16? So there is two numbers that can give me 16 in this case. I can take 4 square, it gives me 16, and I can take negative 4 square as well, and it still gives me 16. So the objects of 16 in this case is 4 and negative 4. So number 4 is given that fx equals to x plus 4, fgx equals to 5 minus 3x, gm equals to n. Express m in terms of n. So fx equals to x plus 4, fgx equals to 5 minus 3x, gm equals to n. Sure. So what we have here is we want to work with gm n equals to n because they ask us to express m in terms of n. So the only way to do that is we have to work from g. So to get g, we can take the composite function. So I write this as fgx equals to 5 minus 3x. So from here, we know that gx, this is technically how a function works. When if I were to give you an example, if let's say I said fx equals to 2x plus 1, so whatever that happens here occurs here. So if I say this fy, this will become y. If I call it ft, this will become 2t plus 1. And if I called it 3, this would be 2 times 3 plus 1. Right? So if I said fgx, means that the gx will be applied here. So it would mean that I will get gx plus 4 equals to 5 minus 3x. So I can make gx a subject by simply minusing 4 on both sides. So it will be 1 minus 3x here. So I got gx already. And they asked me, and they gave me that gm equals to n. So means that now I can replace m with x. So it will be 1 minus 3m equals to n. So make m the subject. So minus 1 on both sides. Negative 3m equals to n minus 1. And divide negative 3 on both sides. So we have m equals to 1 minus n over 3. Right, so number 5, x squared plus 2k minus x, kx minus 3 equals 0. Alpha and beta are the roots. So form a quadratic equation with alpha squared and beta squared in terms of k. So x squared plus 2kx minus 3 equals to 0. So the roots are alpha and beta. Alright, so when we are given roots, we usually work with the sorpor, sum of roots and product of roots. Right, so the formula for sum of roots is negative b over a, product of roots is c over a. So the a, b, and c comes from the general form of a quadratic, which is ax squared plus bx plus c, where a is the number in front of x squared, b is the number in front of x, and c is the number that does not have x in it. Right? So based on this, we have sum of roots here. We add the roots together, it's alpha plus beta. So negative b would be negative 2k. A is 1 here, is defaulted at 1 here if there's no number. So product of roots is alpha beta, c is negative 3, a is 1. So alpha plus beta is negative 2k, and alpha beta is negative 3. So form a quadratic equation with roots alpha square and beta square. So I can write my new roots as alpha square, beta square. So again, I'm going to do the sorpor. So why would I do sorpor here? Because if I want to make an equation, we have a formula that says x squared minus SORx plus POR equals to 0. So in order to use this formula, we need to find the sorpor for the new roots. So in this case, we have alpha square plus beta square. Now, common misconception that student makes is that alpha square plus beta square is equals to alpha plus beta square. This is incorrect. This is not equal to, but it is related to it. So how is it related? If you expand this equation, you'll get alpha plus beta multiplied by alpha plus beta. So if you just you can do the shortcut or you can do the long way. So it'll be alpha square plus 2 alpha beta plus beta square equals to alpha square plus oh sorry, my mistake. I shouldn't have wrote this. So alpha plus beta is equal to alpha plus beta square. Yeah, it's like that, right? So to make it a bit easier to see, I'll write it on left to right. So it would be instead alpha plus beta squared is alpha plus beta times alpha plus beta. So from here we have alpha squared plus 2 alpha beta plus beta squared, and this is equivalent to alpha plus beta squared. So we have alpha squared and beta squared. So if we make alpha squared and beta squared a subject, we actually get alpha plus beta squared minus 2 alpha beta, because I'm gonna take away the alpha and beta here and take away on this side as well. So it will be alpha plus beta squared minus 2 alpha beta equals to alpha squared plus beta squared. So now we have another expression for alpha squared plus beta squared. So instead of writing it like this, I can now replace it with this. So it will be alpha plus beta whole thing square minus 2 alpha beta. And from the previous question, from the previous equation, I know what's alpha plus beta. It is negative 2k, so it's negative 2k squared minus 2. Alpha beta is negative 3, so it's negative 3 here. So it's 4k squared plus 6. So this is my SOR. So my POR is alpha squared plus beta squared, and you can factorize the square here. So it'll be like this, and alpha beta is given as negative 3 squared, so we have 9 here. So finally we have x squared minus SORx plus POR. So my SOR is 4k squared plus 6, so I'm just going to put it in. And my POR is 9, so I'm going to put in 9. And this is my new equation here. Right, so a straight line y equals k plus 1 intersects the curve 3x squared plus xy equals to negative 3 at 2 points. So find the range of values of k. So we have a straight line y equals k plus 1, and 3x squared plus xy equals negative 3. If they intersect at 2 points, basically means that straight line is here, the curve is something like this, and we have 2 points here. So if you guys notice, they ask us for the range of values of k, and this is technically related to one of the subtopics we have, which is the quadratic equations. Now if you recall from the quadratic formula, x equals to negative b plus minus square root of b squared minus 4ac over 2a, we know that this thing here is called the discriminant. So discriminant is basically a short for discrimination. So what is it discriminating? So it's discriminating between the type of roots, right? Which will fulfill which condition will fulfill which roots. So if you have two unique roots, or we say different roots, two unique different roots, we have to make sure that this value here is greater than 0. Because if you square root a number that's greater than 0, such as 4, you will get 2 and negative 2, which is two answers, and you will get those two roots. So we can say that for two different or unique roots is b squared minus 4ac greater than 0. I'm sorry, I think you guys didn't see the example here because I just realized that I put my camera there. So yeah. So if we ask for two equal roots means I need only one solution. So it would mean that b squared minus 4ac is equivalent to 0, because if you square root of 0, you get 0. There's only one answer. So we say b squared minus 4ac equals to 0 here. And finally, if there are no roots, sometimes known as complex roots, we say that b squared minus 4ac is less than 0, because if you have a negative number in here which is less than 0, you are square rooting a negative number. So at this level you don't learn this yet, but we generally say that you can't do this, right? You're supposed to get a complex number, but you can't do this actually at this level. So since we know this, since we know also that it intersects at 2 points, so we will take this, because this is roots generally is defined as an x-intercept or an intersection point. So we can say that b squared minus 4ac is greater than 0 in this case. So before we do that, we need to work out an equation, because if you notice, the x and y on these two coordinates are different, but on the line and the curve they are exactly the same. So we can say that this is equation 1 and this is equation 2, so I can say sub 1 into 2 because they share the same coordinates at those 2 points. So 3x squared plus x times k plus 1 equals to negative 3. I'm substituting y into this part here. So 3x squared plus kx plus x equals to negative 3. So this looks like a 4, I'm sorry. So 3x squared plus, actually I don't need to expand this, so it will be k plus 1 x plus 3 equals to 0. I add 3 on both sides. So from here, b squared minus 4ac greater than 0. So according to the quadratic general form, it will be k plus 1 square minus 4, a is 3, c is also 3, greater than 0. So k squared plus 2k plus 1 minus 36 is greater than 0. So k squared plus 2k minus 35 is greater than 0. So I can use the cross method or use a calculator to solve this. So I have k minus 5 and k plus 7 greater than 0. So when I solve this for 0, is k minus 5 equals 0 and k plus 7 equals 0. So I'll get k equals to 5 and k equals to negative 7. So when I draw the curve, I get this as negative 7 and this as 5. So since it's greater than 0, we assume that this line is 0, right? So if you're greater than 0 means you have to be above the line. So in this case, we will shade in this direction. Therefore, since we shade in this direction, our range is from here and on here. So mind the space, I'm just going to erase a bit on the right side. So I'm just going to erase this. So since we know this, we have here and here, which is k is greater than 5, k is less than negative 7. So this answer means that you have to use values of k which is greater than 5 or less than negative 7 in order to make sure that this criteria is met. In order to make sure b squared minus 4ac is met, greater than 0 is met. Because if you use any value in between here, you are not going to meet that condition. You can try it out on your own time, but most definitely you will not meet the condition at these 2 points here, right? So that's why we say the answer is k greater than 5 and k is less than negative 7. So it is given that a quadratic function y equals to ax minus h squared plus k, where a is greater than 0, has a negative discriminant. So sketch the possible graph. So okay. So earlier on, we've talked about discriminants as well. So for discriminants again, what is a negative discriminant? A negative discriminant generally means there are only 3 types of discriminant types. There's only 3 types of discriminants in this case. So it's either greater than 0, equals 0, or less than 0. So for negative means it's less than 0. So when we say no roots, in other words, we have no intercepts. So since we have no intercepts, the graph will not touch the x-axis at all. So the graph is expected to look something like this, right? So it's not gonna touch the graph, it's not gonna touch the x-axis here. So we can have the rough sketch like that, and a is greater than 0. So for a greater than 0, we know that from the general form that ax squared plus bx plus c equals 0. As long as the term in front of x squared is greater than 0, we consider it as a minimum graph. Whereas a is less than 0, which is negative, we consider it as maximum graph. So easy way to remember it is that positive is happy, so we have a smiley face here, U-shaped, and negative is sad, so we take it as an N-shaped graph in that sense. So this is our rough sketch. That's about it. It's only 1 mark, so don't need to be too keen on the details. Probably just, yeah, just like that. So B, given that the quadratic graph is reflected at y equals to b, find the range of b such that the image of the graph has a positive discriminant. So now they want us to get a graph that can do this, right? It has to reflect. So y equals to b, we don't know what is b, so basically the line can be anywhere here, right? But in order to have a positive discriminant means that we have to have 2 unique roots. Or, in other words, you intercept the curve at 2 points, right? So, we can't exactly guess where that line is here. So I'm just going to erase, actually I'll just redraw it. So I'm just going to draw it a bit bigger, right? So, we can't actually guess where that point is, but we can work with what the information provided us. So if you notice, the way that this equation is structured, this is actually in vertex form. So the purpose of vertex form is basically to find the min or the max point. So in other words, we know what is the min point for this, because it's a minimum graph, it's a min point. So this is the x coordinate, and this is the y coordinate. So if we set this to 0, x minus h equals 0, x equals to h, and the y is k. Therefore, the minimum points coordinate is h, comma k. So this is h, and this is k. Whoops, too big. So now, we have this to start with. So if I want to reflect it, I can try my luck by cutting this into half, right? So I call this line is y equals to k over 2. So y equals to k over 2, the reflection will end up giving me this, right? It touches this at 1 point. So this is not what we want either. This is b squared minus 4ac equals to 0, right? So, but this is where we can start. So that means if I draw the line any higher than this, I will get positive discriminants. So in other words, as long as it's you are greater than the dotted line, you will get a positive discriminant. So I can say that y is greater than k over 2. Or in other words, since y is b, we can say b is greater than k over 2. In that sense. So this is our answer. This is the range of values of b, such that the graph will have a positive discriminant. So 3 consecutive terms of arithmetic progression, 3m minus 2, m plus 3, and 4. So find the value of m. So they are consecutive terms. They didn't tell us what position it is, but they are consecutive. So it means to say I can call this Tn, I can call this Tn plus 1, and I can call this Tn plus 2, right? Why? Because imagine if n is equals to 1, so if you sub into 1, it's like T1, T2, T3, and so on and so forth, right? So why do I need this? Because if they are consecutive, means they have a common difference, right? So to find the common difference, I can say that it is Tn plus 1 minus Tn, or this is also equivalent to Tn plus 2 minus Tn plus 1. So from here I can make an equation, m plus 3 minus 3m minus 2 equals to, this have to be bracket, 4 minus m plus 3. So from here, m plus 3 minus 3m plus 2 equals to 4 minus m minus 3. So negative 2m plus 5 equals to 1 minus m. So let's make m the subject. So we plus m on both sides. So it will be negative m plus 5 equals to 1 minus 5 on both sides. So negative m equals to negative 4. So m equals to 4. I didn't use the space here, so I'm so sorry that it became small. I need to make use of the space a bit better, sorry. So question 9. So diagram 2 shows two salary schemes offered by companies. Scheme A is yearly increment of 150. Scheme B, yearly increment of 6%. So Amirul chose scheme A, Shafiq chose B. It is given that both of them started to work at the company at the same time. Starting salary is 1,006. Given that both of them start to save 10% of their salary when it reaches 2,500. That's very long. Find out who start to save first and how much is his total savings in his first 25 years. Alright, so why don't we just work with two parts? There are two parts of the question. Who saves first and how much do they save in total? So who saves first is generally what we know as, we can find out because they use different schemes. So we start from Amirul. So since the increment yearly is 150, I can think of an arithmetic progression for this because I can say that using the arithmetic progression formula, Tn equals A plus N minus 1D, I can say that A starting money or starting income is 1,006 and D is 150 because his money increases every year where N is years, right? So I can work this out. So when he reaches 2005, I need to find out. So I have to put an equation like this. Tn should be greater or equal to 2005 because I never know, maybe that year he got 2004 then suddenly 2550. So we have to find from here, when did he start getting that amount of money? 2005. So from here I can make the equation 1,600 plus n minus 1 times 150 greater equals to 2005. So 1,600 plus 150n minus 150 greater equals to 2,500. So I'm just going to make n the subject, so it's plus 450 greater equals to 2005. So minus 15450 on both sides. So 150n greater equals to 2,500 minus 1,450 is 1,050. So n is greater equals to, divide 150 on both sides. So how much is that? Is that 7? Oh, that's 7. So n is greater equals to 7. Therefore, we know that n is equal to 7. Right? So that's, it took 7 years for Amirul to reach that amount. So now for Shafiq. So Shafiq, I'll just write here. Hopefully I don't block. I think this should be enough space. So for Shafiq, yearly increment by 6%. So this seems to me more like a geometric progression in this case because his amount of money increases 6% every year. 6% can be written as 1.606. So I can say that his starting income is 1,006 and his R is 1.06 to the power of n minus 1. So again, I need to find out when does he reach 2,500, right? So 1,600, 1.06 n minus 1 greater equals to 2005. So divide both sides by 1,006. So I'll get 1.06 n minus 1. Okay, this one is a decimal. So 1.5625. So when there is an unknown in the power, we take log on both sides. So I'm just going to take log 10 on both sides. So it'll be, why I take log 10 is because I can actually use the log rule to move the power to the front. So it'll be n minus 1 log 10 1.06 equals to log 10 1.5625 and make n minus 1 the subject. So divide log 10 1.06 on both sides. So n minus 1 is equals to, just gonna calculate it, log 1.5625 divide by log 1.06. It is log 1.5625 divide by log 1.06. Yeah. So it's 7.659. So make n the subject, add 1 on both sides, you'll be 8.659 greater equals to So in this case, because it doesn't make, since his money increases every year, it doesn't make sense for us to say that n is 8.6 because he gets his increment every year. So n equals to 8, he doesn't have enough yet. N equals 8.6, he doesn't get the increment yet. So we have to take it as n equals to 9 in this case, because at the 9th year he will have enough money to reach 2,500, right? So in this case, unfortunately, Shafiq loses. So Amirul wins here. So we don't care about Shafiq anymore, so I'm just going to erase Shafiq away. I'm sorry, Shafiq. Maybe another time, another question. Right. So from here, just gonna erase. I need the space for this part. So second part, we have they want the total savings in his first 25 years of working. So the thing is that he only starts saving 10% of his salary after he reaches 2,500. So technically speaking, he only can start saving from the 7th year to the 25th year. So I can't just simply write S25 because S25 means that I'm starting from the 1st to the 25th year. So what I do know is that since S25 can be written as the 1st to the 25th year, I'm just going to draw a line here. This is S25. I don't know what's this, but I know that from the 1st to the 6th year, I can call it S6. So in other words, I can find out what this is by taking S25 minus S6. Right? So I'm just going to work from there. So S25 minus S6, using the formula for S is n over 2, which is 25. I'll just write down the formula here, so in case any of you do not know the formula, Sn equals to n over 2, 2a plus n minus 1d. So from here, 25 over 2, bracket 2, a is, his starting amount is 1,600, plus n minus 1 is 24, d is 150. So this will minus S6, which is 6 over 2, 2 times 1,600, 6 minus 1 is 5, 150. So from here we're going to count, so 25 over 2 is 12.5, so 2 times 1,600 plus 24 times 150 is 6,800. So minus 6 divided by 2 is 3, 2 times 1,600 plus 5 times 150 is 3,950. So I'm just going to multiply and times. Right, so we get 73,150 ringgit. Now, this isn't the correct amount because don't forget, he saves 10% of that salary when it reaches 2,500. So in other words, he saves this amount every month, right? So because he gets salary monthly, not yearly, right? So we have to multiply it by 12, and not only that, we need to multiply it by 10%, which is 10 over 100. So from here, we have 73,150 times 12 times by 0.1. So the total amount of money he would have saved is 87,780. Wow, that's a lot of money. So yeah, Amirul is rich after 25 years of working. He has a lot saved up. Right? So number 10, in a geometric progression, the common ratio is 3. Sum of the first 3 terms is 65. So R equals to 3, S3 equals 65. So find the sum of 2 consecutive terms after the third term. So normally, what students would think when they see the S3, they would say that, oh, we are going to use the Sn formula where a Rn minus 1 over R minus 1 because R is greater than 0. But the problem here is that you know what's R, you know what's 65, but you don't know, but you have to find out what is A. So you can use this, but a more efficient way sometimes is we can just break it down generally, where S3 can just be written as T1 plus T2 plus T3 equals to 65, right? So from here, A plus AR squared equals to 65. So if you factorize the A, it'll be 1 plus R is 3, R squared is 9 equals 65. So in other words, this is 13A equals 65 and divide by 13 on both sides. So A is 5. Not saying that you can't do this, but I just find the one in blue a bit more efficient because this is S3, A you don't know, Rn is 3 to the power of 3 minus 1 over 3 minus 1. So S3 is 65, so this is A. 27 minus 1 is 26, 3 minus 1 is 2. So we gotta do a few operations here. This is 130 equals to 26A. A is 5. You can do this as well, but I just personally prefer the one in blue. Right? So they say find the sum of 2 terms after the third term of the progression. So we basically need to find what is T4. Sorry, I should go back to blue. We need to find out what is T4 and what is C5, and we need to add them together. So T4 plus C5 is AR4 plus AR5. A is 5, R is 3, A is 5, R is 3. So we have 5 times 3 to the power of 4, that is 405, and we have 5 times 3 to the power of 5, that is 1215. So that is 1215 plus 405, and that is 1620. Right? Oh wait, this is oh, my mistake. Because T4 is not AR4, my mistake. So this is supposed to be AR3 and AR4. Ah, that's better. Okay, yeah. Because the formula is Tn equals to ARn minus 1. Yeah. Okay, my mistake. So not 405, not 1215. This is 5 times 3 to the power of 3 is 135. And 5 times 3 to the power of 4 is 405. And we add them both together, we have 540. Done. Right, moving on. So 11, variables x and y are related by the equation y over 4 equals to x plus 3 over x. The equation is reduced into linear form, y equals to 4x plus 12, so it's reduced to this form. So express x and y in terms of x and or y. So since there are no fractions here, I guess I'll just work with I'll just expand the fractions and see what happens. So I'm just gonna multiply 4 on both sides. So I'll have y equals to 4x plus 12 over x. So I can start to see the relation between this and this already, just by doing that. And since this does not have an x over it, so I'm gonna multiply both sides by x as well. So it'll be xy, here x, and here x as well. So it'll be xy equals to 4x squared plus 12. So from here, since I can see the relation here, the numbers here are exactly the same now. So I can relate x and y with terms. So capital Y is equals to xy, whereas capital X is equals to x squared. Right. So this is my answer. Next up. So okay. So diagram 3 shows a car submerged in water during a flood and the side view of the car tire. Okay. Alright. So we have kind of a tire and a rim, and they gave us the rim diameter, so that's 40.64, and they gave us a section height here, which is 10.73, and we are looking for the shaded region, red region. I can't see the red region, but I'm just going to assume this is the red region. So the red region is somewhere around here, right? So since we know the red region is there, we are looking for the perimeter, means we are looking for this arc length and this chord length. So to find the arc length, we need to generate an angle here to work with, right? So I can see a sort of triangle here. So I can draw a dotted line through here to work out the angle. So I can create a 90 degrees here, and this is a right angle triangle, right? So by taking out that right angle triangle, I have access to some values. So since we know the diameter is 40.64, means I can find out what is this height, because this is the radius of the rim. So this is basically 40.64 divided by 2. So that is 20.32. And this is the radius of the whole thing. So finding the radius of the whole thing, we know that this is 20.32 already. We've calculated it. So we can just add it up with the section height. So the radius is basically 20.32 added with 10.73. So that is 31.05 cm. So from here, we have values to work with in this triangle already. So I'm just going to call this theta. So from here, I can use, because it's a right angle triangle, I can use the trigonometric functions. So I have the adjacent and the hypotenuse. So I'm going to use cos, ka. Because ka is cos equals to adjacent over hypotenuse. So from here, cos theta equals to adjacent over hypotenuse. And I'm just going to solve for theta. So 20.32 divided by 31.05, shift cos, we have 49.12 degrees, right? So this is 49.12 degrees. So since we know one part here, we can find the other part here because these are equivalent triangles. So the total angle in this case would be 49.12 multiplied by 2, and that would be 98.24 degrees, right? So we can find the arc length now. So the arc length is just r theta, So our radius was 31.05, so 31.05 multiplied with theta. We have to convert it to radian because that's how we use for the formula. So the theta is 98.24 times pi, which is 3.142 over 180. So it's 98.24 times 3.142 divide 180 times 31.05. So that is 53.25 cm. So that is the length, arc length. So now we need to know the chord. So if you notice that this triangle is still very helpful because this is actually half of the chord. See here? This is half of the chord here. So we just need to find this length. We can just use either a trigonometric function or just use Pythagoras theorem. Because I know this and I know this. So according to Pythagoras theorem, the chord length is just generally, so Pythagoras theorem is c squared equals to a squared plus b squared. It should be remembered by now. So square root of 31.05 squared minus 20.32 squared times by 2, right? Because we are looking for the whole chord here. So it will be 31.05 squared minus 20.32 squared square root times 2. So that is 46.96 cm. Right? And finally, we can find the perimeter. So perimeter of shaded region. Oh wow, what happened? So equals to 53.25 plus 46.96 equals to 100.21 cm. Okay. Oh, extra space. So okay, if you have the paper, then yeah, you need the extra space. It's a pretty long question. So for 13, diagram shows a straight line PQ. It is given that straight line y equals mx, where m is constant, is perpendicular to PQ, and intersects y equals 2x plus 8 at point n. Find n, basically. So let's work with the first part first. The y equals mx is perpendicular to PQ. So it means that if it's perpendicular, we can work something out with the gradient. So in order to work the gradient, we need to make y the subject. So y equals to half x plus 2, because x over 2 is half x. So this is the gradient of the line. So I can just say the gradient of the line PQ is m, or I say MPQ is 1 over 2. And the gradient of the straight line, I'll just call this ms lah, equals to, I don't know. But we know that because they are perpendicular, MPQ ms equals to -1. This is the formula, right? Where the formula is supposed to be m1, m2 equals -1, right? So MPQ is half, ms is don't know, and -1. So we can solve for the gradient of the straight line, so we'll get -2 here. So since we know the gradient, the line's equation is y equals to -2x. So from here, it intersects a straight line y equals to 2x plus 8. So we can introduce the next line here now. So if they intersect means they share the same coordinate. So I can call this equation 1, I call this equation 2, and I just say equation 1 equals to equation 2, -2x equals to 2x plus 8. So we make x a subject, so it's -4x equals to 8, and divide both sides by -4. So x equals to -2. So since we know x is -2, we can throw it back into the equation. So y equals to -2 times -2, which is 4. So our coordinate of n is -2, 4. Done. So 14, diagram 4 shows a straight line graph passing through x and y. So find the equation of straight line in general form. So there are 3 forms in which we can write straight lines. It is the intercept form, gradient form, and the general form. So the intercept form basically is y over a plus x over b equals to 1. So a and b is basically the y and x intercept respectively. Gradient form is what we all know, y equals mx plus c. And general form is written like this. It's kind of like a quadratic general form, but basically they put everything on one side. So to work, since they gave us intercepts here, it's easier to work with intercept form and then change it to general form in this case. So we have y over the y-intercept is 4 and the x-intercept is -3 equals to 1. So I'm just going to multiply everything by 4. So it'll be y plus 4x over -3 equals to 4, and multiply everything by -3 here and here. So it's negative 3y plus 4x equals to negative 12, and put everything on the left side, adding 12 on both sides. So plus 12 equals to 0, and this is the general form. So diagram 6 shows a triangle OPQ such that R is the midpoint of PQ. Alright, given OP equals A, OQ equals B, find OR in terms of A and B. So we can work with OR. So we can say that OR, in other words, to get from O to R, I can say that we can go either in this way or the other way. Right, so I'm just going to use the way in blue. So OR is generally OP plus PR. So I know what's OP. OP is A, but I don't know what's PR. But I know that R is the midpoint of PQ. So in other words, this is the same length as this. So PR, technically, PR should be equivalent to the half of PQ. It's halfway through PQ. So I can say that PR is half PQ. So what is PQ? So PQ is just from P to Q means I go here and here. So in other words, it would be PO plus OQ. And I know what's PO is just the reverse of OP, which is negative A, and OQ is B. So it's minus half A plus half B. So it is just half A plus half B. And this is done. So diagram 7 shows 2 points. P and Q are on a Cartesian plane. So express PQ in the form of xy. So this is vector. So vector from Cartesian equation means that I actually can start from the origin and move towards P and Q. So I can create vectors for them by just assuming that this is the x distance and this is the y distance. So vector wise, the coordinate here is 3, here is 4. So this should be 3 on the x and 4. So in other words, this is OP is 3, 4. Likewise, I do it for Q, where this is negative 2 and this would be 4. So I go 2 units down and 4 units to the right. So I can say that OQ is 4, negative 2. So in other words, PQ would just simply be I move from P to Q through PO, OQ. So PQ can be written as PO plus OQ. So PO is just the opposite of OP, which is negative 3, negative 4. OQ is 4, negative 2. And then I just add the terms together. So it will be 1, negative 6. Right, so this is the vector PQ. So find the unit vector in the direction of PQ is PQ with a hat. So it's just PQ over modulus PQ, or of the magnitude of PQ. So PQ is just 1, negative 6, and the magnitude of PQ is basically on a Pythagoras. We are actually using Pythagoras theorem for it, because if I draw PQ, this is P and this is Q. Technically speaking, if I want to find the distance of this, I would have to just use Pythagoras theorem to find it very easily. Right? And I already know what is the vector of PQ in this case. So in other words, I know what is the x distance and the y distance of P to Q. The x distance is 1, the y distance is negative 6. So I can use Pythagoras theorem to find this. It's just square root of negative 6 square plus 1 square. So you simply be square root of 36 plus 1. And it will just be square root of 37. Why did I write 36? To make it a bit nicer, maybe I'll write it like this: 1, negative 6, 1 over square root of 37. Right? So it'll be like this. You can also divide it inside, but it will be a bit more messy. So if you divide it inside, it would be 1 over square root 37, and the other answer would be negative 6 over square root 37. Right? It will look something like this. So either one of these answers are acceptable. So 17, the variable u and v is related by the equation v equals 36 over u cubed. So u changes from 2 to 2 minus k. So find in terms of k the corresponding small change in v. So we know the small change of u, delta u, is basically, this is the new minus the old. So it's basically new minus old, and it's 2 minus k minus 2. So it's just negative k. So in order to find the small change of v, we need to use the formula delta v over delta u equals to dv over du. It's approximately equals to. So we need to differentiate the v equation first. So to differentiate this, we have v equals to 36u negative 3. So differentiating dv du equals to 36 times negative 3 u to the power of negative 4. So it will just be negative 108 over u power 4. I'm just going to shift it back down. Right. Earlier on we shifted up, so we're going to put it back down. Easier to calculate. So since we know this already, so we're going to apply the formula now. So delta v over delta u is negative k, approximately equals to dv over du, which is negative 108 over u power 4. So delta v is approximately equals to negative 108 over u power 4 times k. So we need to sub in u. We have to sub in the old q, because this is the change and this is the original. So we have to use the original u for this. So it's negative 108 over 2 to the power of 4 times k. So that will simply give us negative 108 over 16, and that is just negative 27 over 4 times k. And that is the answer. So since we know the change in v already, so they ask us to find the approximate value of v. So the approximate value of v, basically the new v, we can say that it is the old v plus delta v. So the old v in this case is, we need to count it. So v equals 36 over u cubed. So 36 over 2 to the power of 3, and that is 9 over 2. So it's just 9 over 2 plus delta v is negative 27 over 4k. So it's simply 9 over 2 minus 27 over 4k. Right, so you can just leave it like that. I think it should be okay. Yeah. Okay, so 18. So diagram A shows the curve y equals fx with gradient function 2ax minus 1. So its minimum point is 4, 3. Find the equation of the curve. So they gave us a gradient function. So gradient function is basically dy dx, which is equals to 2ax minus 1. And they told us the minimum point is 4, 3. So it's important to know this because the minimum point is basically a point where the gradient is 0. So dy dx is a gradient function. So in other words, at this point, the gradient is 0. So I can say dy dx equals to 0 when x is equals to 4. So 0 equals to 2a times 4 minus 1. So 0 equals to 8a minus 1. So make a the subject. We add 1 on both sides. And then divide 8. So a is 1 over 8. So find the equation of the curve. So since we know a already, to find the equation of curve, we just need to integrate. So we take the original equation, dy dx equals to 2 times 1 over 8 x minus 1. Integrate both sides with respect to x. So y equals to 2 times 1 over 8 is 1 over 4. So 1 over 4 x power 2, power increases, divide by 2, minus x plus c. So we add the c because there's no limits here, right? Integration without limits or indefinite integrals, we have to add the integration constant, right? So we have a coordinate to work with here, so we can solve for c, right? Similar to how we do for straight lines. So when x equals to 4, y equals to 3. So it is 3 equals to 1 over 4 divided by 1 over 4, x squared is 4 square over 2 minus 4 plus c. So 3 equals to 1 over 4 times 16 divided by 2 minus 4. So it's negative 2 plus c, so c is equals to 5, right? So that is our equation of the curve. Y equals to, so 1 over 4 divided by 2 just to make it nicer, 1 over 8 x squared minus x plus 5. And this is done. So diagram 9. Diagram 9 shows part of the curve y equals gx. So on the diagram 9 sheet, the area that is represented by the following. Okay, that's a bit small. Need to zoom it in. Oh, there we go. Okay, maybe like this. Okay, yeah, that's good. Right. So, okay, negative p dy h to negative q. So, okay, maybe it's a bit tricky to look at this one shot. So let's look at this part first. So this is integrating with respect to y. So we are looking at the y bounds, right? So they integrated from h to negative k. So this is negative k because of the coordinate provided. And this is h. right? Now we are integrating a number here. So what does integrating a number mean in this case? So if we integrate a number like this, so this is actually negative p, or in other words, I can call this x equals to negative p because it's a line like this. I should write it in red. It's a line like this. This is x equals to negative p. So if I integrate this based on these limits, I'm actually finding an area of a rectangle here, don't you think? So I'm generally shading this whole thing here. Alright, so that is what is understood by this. I'll just erase this part because I think we will need to minus off some areas here. So maybe I'll just shade. Yeah, I think why should I should just shade it lah? Huh? Yeah. So this is what we have for now, right? So they ask us to minus the modulus of RP gx dx. So gx is here, r is here. Where's p? I think this is a typo because p is here. I think it makes more sense if they called it negative p instead. Yeah. So negative p, yes, it makes more sense because this is from r to p, negative p, and they modulus it. So if they modulus it means modulus is just a formality that we use when we find negative areas, we're converting to positive. But what the area they're talking about is this green area here. Because when you integrate under the curve, and this is under the curve, or basically the part that reaches the x-axis here. So we are minusing off this part, and then we are minus. So minus and minus is plus. So we are adding r to 0. R to 0, 0 is here. So r to 0 gx dx. Now, I can understand why they put minus here now. In actual fact, it becomes minus. Because, remember when you write limits, if you write a limit, usually it's from big to small. But what happens when you flip the limits? You will get a positive here, you will get a negative answer here. That's what happens when you flip the limits. So r is definitely smaller than 0. So in this case, it is a minus. Because they are flipping the limits from what it should be. Right? The bigger number should be on top. But when you integrate like that, it means they are integrating from 0 to r, so it's here. Right? So we are minusing off these two parts. Yeah, so if we minus off these two parts, means that I'll just take the eraser. Hopefully I don't erase too much. So, okay, that's too much, but never mind. I'll just redraw it. So we have just this area left over. So we're shading here and here. Right, so this should be our answer. So 20. Diagram 10 shows the position of A on the Cartesian plane. It is given that O to A is a unit vector. So unit vector basically means is one unit. So I can call this 1. Alright. So they ask us to find, in terms of t, what is sine theta. So sine theta is basically what is the sine of this. So now sine theta, if you notice, is obtuse. But since it's obtuse, it has an acute equivalent. So I can draw a triangle here. So it will look like this. It will be oh my goodness. So 0 to A, so O to A, 1, 90 degree here, and then I can call this other angle here. I can call this alpha. Alright. So in this case, they want us to find the and we know that this is t. Good. Right? So very simply, sine theta, because this is the obtuse version, this is the acute version. So in other words, I can say that sine alpha is equivalent to sine theta. So in other words, sine theta is equals to, so for sine alpha it is opposite over hypotenuse, so it is just t over 1. So sine theta is just t. Right? So part B, what is tangent to theta? So tangent to theta, we have to follow the formula. So I don't really remember the formula. So tangent to theta, let's see. Never mind. I think I might have one here. Yeah, it is 2 tangent theta over 1 minus tangent square theta. Yeah. So we need to find what's tangent theta. So tangent theta in this case would be opposite over adjacent. So adjacent here, we can find out what is adjacent. So to find adjacent, we can use Pythagoras theorem by just doing, so adjacent is square root of 1 minus t square. Done. So tangent of theta is opposite, which is t, over square root of 1 minus t square. Now, we have to include a negative here. Why? Because tangent theta is negative. Because this angle here is obtuse. If you look at the unit circle, this is the first quadrant, second quadrant, and the third quadrant. Now, we are currently in the second quadrant because the angle is obtuse. So if you are in the second quadrant, sine is positive here and sine is positive here, right? However, tangent is negative here. So since tangent is negative here, tangent theta is negative t over square root of 1 minus t square. So we have to be very careful which quadrant we are in so that we know how much is the value of for the trigonometric function. So from here, we have 2 tangent theta is negative t over square root of 1 minus t square over 1 minus negative t over, oh wow, that's 1 minus t square square. So when we multiply here is negative 2t over square root of 1 minus t square, and this is 1 minus, so I square the whole thing, it will be t square over 1 minus t square when you square on top and bottom. So I don't have enough space, I'll erase the front part here. Right? So from here, I'm just going to, I need to make, if I want to combine the terms at the bottom, I need to make the fraction the same. So I'm just going to multiply the top and bottom by 1 minus t square. So I'm just going to copy this down. So 1 minus t square, square root over. So 1 times 1 minus t square is 1 minus t square over 1 minus t square. Now, to work with this, it's a 4-layered fraction. It's not advisable to work with this, so usually we'll split it into 2 fractions because negative 2t over square root of 1 minus t square is 1 fraction, and it's divided by 1 minus t square is 1 minus 2t square over 1 minus t square. So we can actually change it to multiply, and I'm going to play with the surd here by calling this 1 minus t square power of half. Now why did I do this? Because this is power of 1 and that's power of half. So ultimately, they are dividing each other. So it's 1 minus half, right? Because if I write it like this, negative 2t, 1 minus t square to the power of 1 over 1 minus t square to the power of half times by 1 minus 2t square. You see, what happens here is that this term and this term is exactly the same, but the only thing is different is their power. So it means that 1 divided by this power, this term, divided by this term is 1 minus half. So in other words, I can just get rid of the bottom. I need to erase this part as well. By saying that negative 2t, 1 minus t square, power half over, so this is gone already, 1 minus 2t square. Right? And then this is done. I can't simplify any further than this because this is not the same as this. So this is done. So 21, solve the equation 2 sine square theta cos theta equals to cos square theta minus 1. So 2 sine square theta cos theta equals to cos square theta minus 1. Alright, so I can work with one of the identities. So the identity here we have is sine square theta equals to, sine square theta plus cos square theta equals to 1. So I can probably just work with the sine square theta one. So sine square theta equals to 1 minus cos square theta. Right. So from here it will be 2, 1 minus cos square theta, cos theta equals to cos square theta minus 1. So by multiplying, I have 2 minus 2 cos cube theta. Yeah, 2 times here and times cos. So it's, sorry, I should just multiply the 2 first. 2 minus cos square theta multiplied by cos theta equals to cos square theta minus 1. So multiplying cos will be cos theta minus cos cube theta equals to cos square theta minus 1 in this case. So we have, if we make cos cube theta the subject, so from here we have negative cos cube theta minus cos square theta plus 2 cos theta plus 1 equals to 0. So I'm just gonna make this positive. I'm just gonna change all the symbols. Now, we can solve this if we just use our calculator, right? Or if you do long division, but that's not necessary. So we can do this by saying, if you go on a calculator mode, instead of taking the usual equation, the quadratic, we take a cubic. So it's 1, 1, negative 2, and d is negative 1. So we know that this is a equals to 1, b equals to 1, c equals negative 2, and d equals to negative 1. So from here, oh dear, I made a mistake. So this is supposed to be 2, 2, 2, 2, 2. Ah, okay. I think it's much better now. Because when I key in my calculator, I already saw that the answer is like very weird. That's how I could tell. Right, so I have 3 answers. So I have 1, negative half, and negative 1. So to sort of cheat, I can usually write like this: cos theta minus 1, cos theta plus half, or in other words, yeah, cos theta plus half. And the third one would be cos theta plus 1 equals to 0. And I'll solve for all these 3 brackets. So starting from the first one, cos theta minus 1 equals 0. So cos theta equals to 1. So cos theta is positive. So since it's positive, we are referring to the first and fourth quadrant. Right? So for the first quadrant, if you use calculator, all calculator answers are the first quadrant. So in this case, it's 0 degrees. And then the fourth quadrant, we have to take 360 minus 0, which is just 360 lah. Right? So the next one, cos theta plus half equals 0. Cos theta equals negative half. So theta equals to, so usually from here, if there's a negative here, we usually find the basic angle first. So we say cos alpha equals to half. So the basic angle is the angle in the first quadrant. So it's important because if you just use shift cos on your calculator straight away without finding the base angle, you'll find the angle in one of the quadrants, but you're missing one answer because the calculator doesn't give 2 answers when you shift cos, right? So in this case, we find the basic angle at 60 degrees. So we know that cos is negative in the second and third quadrant. So we have to minus the basic angle by saying that theta equals to 180 minus 60 and 180 plus 60. So this is in the second and third quadrant respectively. So 180 degrees, 240 degrees, right? So from here, the last one, cos theta plus 1 equals 0, cos theta equals negative 1. So find the basic angle first. So alpha equals to, so cos of 1 is 0. So the basic angle is 0. So from here, since we know the basic angle is 0, cos is negative in the second and third quadrant as well. So again, it would be theta equals to 180 minus 0, 180 plus 0. So it's just 180 degrees. So from here, we have 1, 2, 3, 4, and 5 answers. So the answer is 0 degrees, 120 degrees, 180 degrees, 240 degrees, and 360 degrees, right? So alternatively, you can also just make cos square the subject here, as in like you convert, actually no, I think this is probably a more efficient way to work with. Yeah, most likely. Actually, yeah, if you wanted to convert the cos square, you can also do that, but yeah, maybe I'll show it. For anyone who wants to convert or make cos square the subject in this case and convert it to sine instead, right? So it will be, that's my razor. Ah, okay. I think I'll just erase the whole thing. Yeah, sure. So from here, 2 sine square theta cos theta equals cos square theta plus minus 1. So if you make cos square theta the subject, it will be 1 minus sine square theta. So it will be 2 sine square theta cos theta equals to cos square theta. Sorry, I have to replace it already. So it's 1 minus sine square theta minus 1. So we move everything to the left side. 2 sine square theta cos theta equals to plus lah. 1 minus 1 is 0. So it's plus sine square theta equals to 0. So from here, 2, we can factorize sine square theta. So sine square theta is cos theta plus 1. 2 cos theta plus 1, which is equals to 0. Right. So sine square theta equals to 0. And 2 cos theta plus 1 equals to 0. We can solve for 2. Now the problem with this is that there is a little bit of continuity. Yeah, there is I think you will be missing an answer here, most likely, because sine square theta, if we were to just solve sine square theta, we will only get one answer if you notice. So we have to convert this back into cos in that sense. So it'll be 1 minus cos square theta equals to 0, right? So reason why we do this is because if we did sine square theta, we kind of miss out one answer. So usually when you have a square root and you have a 0, you most likely cannot use this way because you are actually missing out on an answer, right? Because square is supposed to generate two answers for you. In this case, cos square theta equals to 1, right? You're supposed to get two answers from here. You're supposed to get cos theta equals to 1 and cos theta equals to negative 1, and then you solve from there, right? So that's why we have to convert. So cos theta equals to 1. So again, I will just put the answer down. So because I did the calculations earlier already, so just to save some time. So it's 0 degrees, and this is shift cos of 1 as well. So this is 180 degrees. And then 2 cos theta plus 1 equals 0. So we have cos theta equals to negative half. So we have two answers here. So that is sorry, 360 degrees as well. So this is 120 degrees, and this is 240 degrees. Right. So we have the same answers here, but just that there's a little bit of a trick here. So I guess the better way is the previous one in that sense. So 22, it is given that 53 and 61 are the lowest and highest mark respectively. So interquartile range is 6. So another student took the same test and scored beta marks. So, that's alpha, sorry. Given that new interquartile range of data is 5, find the possible range of beta. So we need to find out what's alpha first before we can actually start. So usually what we'll do is that we need to arrange everything in a kind of an ascending order. So 53, 53, 54, 55, 56, 58, 59, and 61. Alright, so these 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I didn't put alpha in because I don't actually know what alpha is, right? However, they did specify that 53 and 61 are the highest and lowest, so we can fix it like that. So alpha is not in front or behind. So, sorry, alpha cannot be here and alpha cannot be here, right? So interquartile range is 6. Now, interquartile range is simply Q3 minus Q1. So the third quartile minus the first quartile has to be 1 in this case. So how do we find the third quartile minus the first quartile? So what are the possibilities for us to get a third quartile and first quartile as 6? So if we split the data into half here, I'm just going to split into half here. So there are some possibilities that we can actually use to count. So we can take a few assumptions here, because you see 53, between 53 and 53 is still 53, right? Between 53 and 54 is 53.5. Between 54 and 55 is 54.5, right? And between 55 and 55 is 55.5, 56.5, 56.5. Oh my gosh, my writing. 57.5, 56.5. So 57, assuming that alpha is 58, it could be 57, it could be 58, it could be in between 57.5, 58.5, and so on and so forth. 59.5, 61.5, and so on. So there are many possibilities of what value can happen, but we have to make a smart guess in this case. So what I'll normally do is, okay, to make a smart guess here, maybe the value is, because it's towards the left side here, it's probably around this or this, 53.5 or 54.5. It should be either one of them, right? Because if you notice, in order for you to get 6, you should only do 59 minus 53, or you do 60 minus 54, right? Or if you want, 58 minus 52. However, all of these values are kind of far. It's kind of not intuitive anymore, because see, 52 you can't use 52 because this is too far, right? It's out. And 60 minus 54, 60 is too deep in here, right? And 54 is still just nice, but 60 is a little bit too deep into the thing, so we can't use this as well. 59 minus 53 is probably our best bet, but it means that we need to find out what is that value of alpha that can actually make it work, right? And can we get a value like that? So assuming that, okay, alpha is 59. Now if you put alpha as 59, it means that our interquartile range here is 59, but it's not the same for the other side. So 53, 53, 54, 55, 56, 57, 59, 59, 61, assuming that alpha is 59. So your median is now here. So you see, Q3 is 59, Q1 is 53.5. Doesn't work, because the first quartile becomes 53.5. So because this doesn't work, we have to take the 0.5 values now, because all of the whole numbers don't work anymore, right? So since all the whole numbers don't work, I'm just going to get rid of it. So what 0.5 values can actually get us to this? So I can say that probably is 59.5 minus 53.5. Yeah. Or I can say 60.5 minus 54.5, right? Now, I can't take this because it's too far to the right again, right? It's too close to this side, right? And 54.5 is just nice, but it's because of 60.5, right? We have the same problem again. So the one that's closest to this would be 59.5 and 53.5, right? So since 59.5 and 53.5 is closer, so I need to know what value can give me 59.5 in this case. So what I can try is, I can try to assume that alpha is 60 here, right? So 53, 53, 54, 55, 56, 57, 59, 60, 61, right? So when I make this assumption, now we can see that 59.5 comes to play, and 53.5 also comes to play. So from here we know that alpha is 60, right? So that's how we can find our alpha. So now the question doesn't want alpha, the question wants beta. So but we need alpha first. So since we know alpha is 60, now we're going to work with beta. So beta, given that the new interquartile range of the data is 5 after they put beta in, so find the possible range of B. So we need to test again. So making smart guesses, right, means that I would be putting beta either in the front or the back, right? Because 53, 53, 54, 55, 56, 57, 59, 60, 61. Now that I have a median here, so if this is the middle, means that beta needs to either be here or beta needs to be here. There's only two ways to put it, right? Because if you follow the IQR again, so now the interquartile range is 5, means that Q3 minus Q1 must equal to 5, right? So in this case, beta can either be on the left or the right, because there's a range of values here, right? We have to play with some values here. So we can't possibly count everything because we need to find it faster, right? This is only a 3-mark question. So because we can use this, we can work with this, we can play with it. Because if let's say beta is on the left side, I wouldn't know what my Q1 is. But if beta is on the left side, means that my median has now shifted here. So since my median has shifted here, means that I can find Q3. Q3 will be 59. So if you see, 59 minus Q1 equals to 5. Therefore, Q1 has to be 54. right? So Q1 must be 54 if we put beta to the left. So what values of beta can give me a Q1 of 54? Means that beta can't be 53, because if I put beta here, my Q1 will be 53, but means that beta can be 54. Beta can also be 55. So we found the two values of beta that can work if beta is on the left side. So we're going to repeat this process for the right side. So when we do it for the right side, so now 53, 54, 53, 54, 55, 56, cut, 53, 54, 55, 56. Oh, there are two 53s, right? Yeah, cut. So let me just erase this again. So 53, 53, 54, 55, 56, cut, 57, 59, 60, 61. Right? So from here, in this case, beta, we know that IQR is 5, Q3 minus Q1 should be 5. So now we know what is our Q1 already. So it will be Q3 minus 54 equals to 5. Right? So Q3 minus 54 equals to 5 means that Q3 equals to 59. Q3 must be 59. It must be this. So the values of beta that can make 59 the median is, the Q3 is when beta is 56, beta is 57, if beta is 56 is here, beta is 57 here, beta is 58 also can, beta 59 also can, right? All these four values will allow our Q3 to be 59. Therefore, the range of values of B would be beta less than equals to 59, less than equals to 54. Beta can be any value between 54 and 59, inclusive. Right? So this is done. So heading 3, diagram 11 shows a spinner for Bonanza price. Customer will get a chance to spin once for every $500 purchase. So given that Henry spent 1,200, find the probability of him winning different prizes. So, okay, sure. So why don't we find the probability for getting a prize in the first place, right? So what's the probability of him getting 50 ringgit? So to get 50 ringgit basically is we can play with the angle 150 degrees over 360 degrees. This is simple probability. So 150 divided by 360 is just 5 over 12, right? Because from the formula for probability is probability of x would be number of x over number of sample. So number of x means how many x's are there, or how many chances to get x are there, or ns is how much is the total, or how much is the total of everything in that set. So in this sense, this set is a circle. So 50 ringgit takes 150 degrees off that circle, and the whole circle is 360. So 150 divided 360 works. So we can do the same for P of the, what's this? Oven? I guess it's an oven, kind of. Oh, it's a microwave lah. So I'm called micro lah. So P micro is 90 degrees over 360. So its chances of getting it is 1 over 4. And 100 ringgit, they didn't give an angle, but we can find it just by doing 360 minus 150 minus 90 over 360 equals to 1 over 4. Sorry. Equals to 1 over 4. Must be tripping. So divide by 360. So 1 over 3. Right. So given that Henry spent 1,002, find the probability for him winning different prizes. So he spent 1,002 means he can spin 2 times, because 500 ringgit per purchase, 1 spin. So 1,200 means he gets 2 spins, right? So since he got 2 spins, he can get different prizes. So the different prizes he can get is, let's say outcomes. Let's just talk about outcomes first. So the outcomes is he can get 50 ringgit or 100 ringgit, 50 ringgit then 100 ringgit, and he can do the reverse of that as well. He get 100 ringgit first, then he get 50 ringgit, right? They're still different. So you can also get the 50 ringgit and the microwave, or the other way around, the microwave then the 50 ringgit. And the last one is he get 100 ringgit and the microwave, and the other way around. So we have a couple of outcomes here to work with, right? So since we know all of the probabilities, so we can solve it. So in other words, P550 over P100, right? You notice that the probability of getting 50 and 100 and then 150 is kind of the same thing, because if I write it down, probability of 50 is 5 over 12 times by to get 100 ringgit is 1 over 3, and you see I'm going to add kind of the same thing, 1 over 3 times 5 over 12, right? They are the same thing. So in order to make it easier to write, instead of writing the same thing twice, I can just multiply it by 2. So this is also 2, this is also 2. So it will be plus, probability of 50 is 5 over 12, probability of the microwave is 1 over 4, and the last one is 2 times of probability of getting 100 ringgit is 1 over 3, and probability of getting a microwave is 1 over 4, right? So this eases our calculation a bit, and also eases our writing lah, so that we can write a bit less, right? Need to save time. This is a time-based paper, so we need to try and save as much time as we can. So we have 2 times 5 for 5 over 12 times 1 over 3 times 2. So we have 5 over 18 here. Just going to erase the bottom just a bit. So it will be 5 over 18 plus 5 over 24 plus 1 over 6. So we have 47 over 72. 47 over 42, that looks weird. Okay, better. So 24 is given that x binomial NP and probability of x is equals to 0 equals to probability of x equals to 1. Find the mean in terms of p. So this is a binomial distribution. N sample and p, the probability of success is p. So your probability of success, I should say success lah, is p. So your fail is technically 1 minus p, because your total probability is always 1. So your fail is basically just 1 minus p in that sense. So the probability of x equals to 0 means that when what is the probability of getting 0 of getting 0 successes in that sense. So it means that your total number of trials is n. C, 0 of them are successes. So following the formula, yeah, I should just write the formula first. NCR P R 1 minus P N minus R, right? So basically it is just, this is your trials, this is your number of successes, and this is your probability of successes, and 1 minus P is your probability of failure, right? So these are just simple descriptors for it. So NC is 0, P is P, and your R is 0. So your probability of failure is 1 minus P, and this will just be N minus 0, right? So this is supposed to be equal to when you have one success, so NC1, and this is P1, and this is 1 minus P, N minus 1. Alright, sure. So NC0 is just 1, P power 0 is just 1, and this is 1 minus P, N minus 0 is just N. So NC1 is N, P power 1 is P, 1 minus P, I can't really expand this, so I just write it like this, right? So I have 1 minus P to the power of N equals to N P, 1 minus P, N minus 1. Now interestingly enough, we know that the mean for binomial distribution is NP. So technically, we can just make NP the subject here. So if you make NP the subject here, it would be 1 minus P power of N over 1 minus P power of N minus 1 equals to NP. Now this term is the same. So according to indices, we can minus these two because it's divide. Because AM divide AN equals to AM minus N. So in other words, we can minus the power So we have np equals to 1 minus p to the power of n minus n minus 1. So np equals to 1 minus p, so n minus n is 0, so negative negative is positive. So we know that the mean is 1 minus p. Last question. So company XYZ is looking for 4 new employees among 7 candidates attending the interview. The company's policy does not allow husband and wife to work together. Given there is a couple of husband and wife, a couple are one. So find the number of different ways to select the new employees. So 1, 2, 3, 4, 5, 6, 7. So there is a husband and wife, so H and W, right? So now it's difficult to count how many outcomes there is where there is no husband and wife, but it's easier to count the complement of that. So the complement of that is just the total minus minus the ways with the husband and wife. So now we are gonna need to find the total ways to arrange, and we're gonna minus that with the ways in which the husband and wife works in the company as well, right? So how we do that is that first we find the total. So the company is looking for 4 new employees out of 7 candidates. So out of 7, we need to choose 4. Now we use C because we don't care about who comes first. We care about who comes in, right? So C is disregarding the order in which they come in. So 7C4 is 35. So this is our total. So we need to find the ways in which the husband and wife comes in. So in other words, the husband and wife are already in the company, we have to assume. So if the husband and wife are already in the company, means the number of people left would be 5. And the number of spots left would be 2. So in other words, the ways in which the husband and wife are in is just 5C2, right? So 5C2 is just 10, right? Therefore, we can find, so the ways where husband and wife not hired is equals to the total minus the ways the husband and wife are hired. So from here, we can find as total is 35. Husband and wife not hired is 10. So answer is just 25. Done. Nice and easy, right? So you don't need to write like all of these words like this, right? You can write it in shorter forms. So like maybe no husband wife or with husband wife, but I'm just writing it just for clarity. Right, so this is the end for MRSM 2020 paper 1. So I hope this is beneficial for you. If there are any parts in which I didn't explain properly or you would like a better explanation, please let me know. I can make another video for it, and specifically focusing on the question itself so that I can break it down even better or explain it in more detail. Right, so please let me know in the comments if you guys have anything to comment about, problems with my language, problems with my explanation. Please let me know. I would like to learn more so I can improve as well. So thank you so much for tuning in, and I hope to see you guys in the next video.